Hello students, welcome to RD Chemistry. Here I will discuss preparations and acidic nature of carboxylic acids. First method is oxidation of alcohols. Alcohols can be written as the RCH2, which primary alcohols are easily oxidized in the presence of oxidizing agents like potassium permanganate, dichromate to give RCH2. But the reaction doesn't stop at the aldehyde state. They further oxidize to give carboxylic acids. We can also make use of CrO3 in sulfuric acid, which is also called as the Jones reagent. It is known as the Jones reagent. Okay. Preparations can be done by acid halides esters by the process known as the hydrolysis. Acid halide is like acid chloride, say RCOCl. In the presence of water molecule, acid medium, basic medium. Let me write in terms of water. Break this carbon chlorine into two parts. H and OH to the water molecule can be added to give RCOOH plus hydrochloric acid. Esters have formula R, C, double bond O, O, R dash, right? In the presence of acid hydrolysis, basic hydrolysis, what you have to do is add water molecule across carbonyl group and oxygen to give carboxylic acid RCOH and R dash OH alcohol. Correct? Next one is from Grignard reagents. Grignard reagents are the formula RMgX, and this is a charged reagent. So this is a R minus and Mgx plus part, polar species. It reacts with the solid carbon dioxide, that is only dry ice. So we have got a partial positive charge, partial negative charge. So nucleophilic R minus attack the carbon atom, and the magnesium halide go to the oxygen to give addition product R, C, double bond O, O and Mgx. These are salt form. On hydrolysis, finally they give rise to the carboxylic acid and the magnesium salt, magnesium with the OH group and the X. Remember here, CO2 group comes from the carboxylic group comes from the dry ice, that is the CO2 group. Okay. From nitriles also we can prepare. Nitriles also called the cyanides. Suppose I have got R, C, triple bond N. So suppose is subjected to hydrolysis. Break the bond in two parts now and write water molecule like this to give R, C, double bond O, NH2. So this is called the partial hydrolysis. But when it's subjected to hydrolysis again, okay, so finally this give rise to, again write on water molecule like this to give finally carboxylic acid RCOH plus the ammonia. If it is a acidic medium hydrolysis, so finally get like ammonium salt we are going to get. Okay, right? From aromatic hydrocarbons also we can prepare the carboxylic acid, that is the aromatic carboxylic acid. Suppose I have got here the toluene. Toluene is made to react to the potassium permanganate in the presence of the basic medium, and followed by the acidification. It gives finally the CH3 group, okay, getting oxidized to give COH. If there are extra carbon atoms, okay, they'll be becoming the corresponding carboxylic acid. Now if I take this, okay, tertiary butyl benzene, okay, for the oxidation, the alpha carbon atom which is attached to the, okay, this carbon which is attached to again benzene, there must be alpha hydrogen. In this case, this carbon doesn't have the alpha hydrogen, only CH groups are there, therefore there is no oxidation, so there is no carboxylic acid formed. Okay, right? Now let us see acidic nature of carboxylic acid. There are two important groups which can affect the acidic nature of the carboxylic acid, right? So effect of electron withdrawing groups, generally they increase the acidity of the carboxylic acid. Remember here, as the number of electron withdrawing group increases, acidic nature also increases. For example, let me take a CH3 COOH. Compare with the chloro derivative. Cl is a electronegative electron withdrawing group. Okay, so compare now. When an electron withdrawing group is there, acidic nature increases, acidic acid weaker acid. Also, closer the electron withdrawing group to the COH group, stronger is the acid. Suppose I take a CH3, CH2 and say COH. This is a propanoic acid. Now what I'll do, I'll introduce on the alpha carbon atom, the chlorine atom. Or I'll take one more molecule, propanoic acid, but I'll be introducing the chlorine on the beta carbon atom, then here CH2, then COOH group. When the electron withdrawing group is very closer to the COH group, is a stronger acid compared to the next molecule here. Okay, right? Acidity of carboxylic acid also depends on the strength of the electronegative atom. Remember, fluorine is more electronegative compared to chlorobromoiodine. So suppose I take fluoroacetic acid and compare with the any other, okay, say let me take bromoacetic acid, which is more electronegative atom here, fluorine. So it will be more stronger acid. Okay, right? Let us see what will do these electron donating groups. Electron donating groups, they decreases the acidic character, or as the number of carbon atom in the alkyl group also increases, acidic nature also decreases. So compare the basic one, formic acid, then acidic acid CH3 COH group, then let me take a propanoic acid CH3 CH2, then COOH group. Okay, so alkyl groups generally decreases the acidic character. As the number of carbon atom increases, acidic acid still decreases. They formic a stronger acid compared to acidic acid compared to propanoic acid. Okay. Now let us see the acidity of the aromatic carboxylic acids. Electron withdrawing group increases the acidic character. Electron donating group decreases. So let me take the benzoic acid. Okay, 3 types of benzoic acid. In one of the compound, let me introduce the electron withdrawing group, NO2 group. NO2 group, electron withdrawing group, acidic character increases compared to the basic benzoic acid. Now let me take on this side, okay, OCH3 or CH3 group. Okay, these groups are electron donating. So when compared to the benzoic acid and the electron donating groups attached, benzoic acid is the stronger acid. Okay. Now there is also something called the ortho effect. Ortho effect. If there is a substituent on the ortho position, they are the stronger acid compared to remaining para and meta substituted groups. Let us see those things in the questionnaire, in the MCQs. Okay. Which of the following on heating with the aqueous KOH produces acetaldehyde? So let me take this one first on. Now we are taking a K plus OH minus in the aqueous medium, correct? So Cl can be replaced by the stronger nucleophile, that is OH here, will get alcohol. Now if I take this one, this is a CH2Cl, CH2Cl. If I introduce the OH groups, nucleophile substitution reaction, we are going to get diols here. Okay, not the answer. But if I take this one, third option, CH3CH, there are 2 Cl. The Cl should be replaced by the OH group. Nucleophile substitution reaction. If there are 2 OH groups on the same molecule, same carbon atom, it loses a water molecule to give finally CH3CHO. So we are going to get acetaldehyde from the third option. Third one is the answer. What about the fourth one? Break this carbonyl Cl bond. So we'll get here CH3CO. Instead of Cl, write on OH, we'll get acetic acid. Answer for this question is option number 3. Okay. In the following reaction, the product P's. This is a Grignard reagent RMGX. when treated with the carbon dioxide and then acidified in two separate steps, we are going to get a corresponding carboxylic acid, correct? So R becomes RCOH. So therefore benzene should be converted to its carboxylic acid. Therefore answer is option number 2, right? Question number 3. Consider the acidity of the carboxylic acid. The pH stands for benzene. So we have got here, first one is the benzoic acid. Second one, orthonitrobenzoic acid it is. Orthonitrobenzoic acid. Third one is the para-nitrobenzoic acid. Para-nitrobenzoic acid. Para-nitrobenzoic. And then we have got meta-nitrobenzoic acid. Meta-nitrobenzoic acid. Correct? Now, NO2 group we have got here is electron withdrawing group. So therefore, acidity of nitro derivatives must be greater than that of the standard molecule, that is the benzoic acid. Now here, you have to remember something called the ortho effect. Whatever the group attached to the ortho position in the aromatic carboxylic acid, they are the strongest acid. That means orthonitrobenzoic acid is the strongest acid. So Roman number 2 should be first, stronger acid. Okay. Then we have got para-nitro and meta-nitro. Correct? They are electron withdrawing groups. When nitro group is there at the para position, it exerts minus R effect. Okay. Whereas if the nitro is there at the meta position, it cannot have the minus R effect group. But instead it will have the minus I induct effect group. Compare minus R minus I, which is more operative, stronger one. Minus R is more operative. So para-nitro is a stronger acid. So Roman number 3 comes. Then comes to meta-nitro. Okay, that is the option number 4. And all these nitro compounds are stronger acid compared to the standard molecule. First one, benzoic acid. So 2, 3, 2, 3, 4, 1. Option is the fourth one is the answer. Okay. Which of the following true for regarding the acidic nature of the carboxylic acid? Okay. We have got formic acid they are given. They are given acetic acid. Then they are given propanoic acid, CH3, CH2, COH with the 3 carbon atom. Hydrogen is the standard one. CH3 is the alkyl group plus I effect group. And ethyl group is also exerting plus I effect group, electron donating group. Methyl and ethyl will have the more plus I effect group. Therefore, formic acid stronger acid, then the acetic acid, then the propanoic acid. Therefore, answer is option number 1. Okay. Next question, decreasing strength of the acids are given. Now, if I write this structure, first, let me take the first option. Okay, to write these structures, on this CH, there are 2 Cl groups and then COH group. Then, we take the second compound there, CH2, 1 Cl is attached, then there is a COH group. And last one, there in the first option is the acetic acid, CH3, COH group. Cl groups are electron withdrawing groups, electronegative. More the number of electron withdrawing groups, stronger is the acid. Then comes the monochloro, then comes the acetic acid. Dichloro, acetic acid, stronger acid. Therefore, first one itself is the answer. Okay. Question number 6. In the anion RCO minus, 2 carbon oxygen bonds are found to be of equal length. What is the reason for that? Now, we have got the carboxylate ion once it loses the H plus ion. Then we have got here anion is involved in the resonance with the CO group. Therefore, we are going to get one more structure RCO minus double bond O. Now, if you see in both the cases, oxygen contains the negative charge. Correct? And these are similar structures, same structure, resonated structures. And they have got same bond length. Right? Therefore, answer should be, if you observe carefully, answer is option number 4th one. The anion RCO minus are the 2 resonating structures. Similar structures look the same. Fine? Students, if you are watching for the first time these videos, please do like, share and subscribe. And please support me. Thank you for watching. Have a nice day.